Now we're going over the factor theorem. The factor theorem tells us that a is a zero of a polynomial p if and only if x minus a is a factor. So if you divide p of x by x minus a and the remainder is 0, then p of a is 0. What does it mean for x minus a to be a factor of p of x? Well, if you divide p of x by x minus a and the remainder is 0, then x minus a is a factor. Just like with numbers, if you divide by a number and the remainder is 0, then that's a factor of that number. So how do we use this? Well, if we want to know if x minus 2 is a factor of a polynomial, say x squared minus 3x plus 2, instead of dividing, now we can just evaluate the function at 2 and see if that's 0. So what is p of 2? Note there's a negative in the factor theorem. It's x minus a. So you're going to evaluate the function at a. So in this case, a is 2. P of 2 is 2 squared minus 3 times 2 plus 2, which is 4 minus 6 plus 2. 4 minus 6 is negative 2. Negative 2 plus 2 is 0. So P of 2 is 0. The factor theorem tells us that if P of 2 is 0, x minus 2 is a factor of x squared minus 3x plus 2. So yes, it's a factor. It also works the other way. If I want to know if a equals 3 is a 0 of this function, I can plug that 3 in, but then it'd be pretty complicated. Or I can divide by the polynomial x minus 3 using synthetic division. So I can just take this 3, put it in my box, and then the coefficients of this polynomial, that's 1, negative 8, 22, negative 29, and 24, making sure if there's anything missing, I put it down, and then I use synthetic division. Bring the 1 down. 1 times 3 is 3. Negative 8 plus 3 is negative 5. Negative 5 times 3 is negative 15. 22 minus 15 is 7. 7 times 3 is 21. Negative 29 plus 21 is negative 8. Negative 8 times 3 is negative 24. And so we have a 0 here. That means that x minus 3 is a factor of p of x. So that means that 3 is a 0 of p. So yes, if this remainder is 0, and then the factor theorem tells us that it's a 0.